Interestingly, Charles Darwin was born a very lightly pigmented man in a moderately to darkly pigmented world. Over the course of his life, Darwin had great privilege. He lived in a fairly wealthy home. He was raised by very supportive and interested parents. And when he was in his 20s, he embarked upon a remarkable voyage on the ship the Beagle. And during the course of that voyage, he saw remarkable things, tremendous diversity of plants and animals and humans. And the observations that he made on that epic journey were to be eventually distilled into his wonderful book on the origin of species, published 150 years ago. Now, what is so interesting, and to some extent what's a bit infamous about the origin of species, is there's only one line in it about human evolution. Light will be thrown on the origin of man and his history. It wasn't until much later, that Darwin actually spoke and wrote about humans. Now, in his years of traveling on the Beagle, and from listening to the accounts of explorers and naturalists, he knew that skin color was one of the most important ways in which people varied. And he was somewhat interested in the pattern of skin color. He knew that darkly pigmented peoples were found close to the equator. Lightly pigmented peoples, like himself, were found closer to the poles. So what did he make of all this? Well, he didn't write anything about it in The Origin of Species. But much later, in 1871, he did have something to say about it, and it was quite curious. He said, of all the differences between the races of men, the color of the skin is the most conspicuous and one of the best marked. And he went on to say, these differences do not coincide with corresponding differences in climate. So he had traveled all around, he had seen people of different colors living in different places, and yet he rejected the idea that human skin pigmentation was related to the climate. If only Darwin lived today. If only Darwin had NASA. Now, one of the wonderful things that NASA does is it puts up a variety of satellites that detect all sorts of interesting things about our environment. And for many decades now, there have been a series of TOMS satellites that have collected data about radiation at the Earth's surface. The TOMS 7 satellite data, shown here, show the annual average ultraviolet radiation at the Earth's surface. Now, the really hot pink and red areas are those parts of the world that receive the highest amounts of UV during the year. The incrementally cooler colors, blues, greens, yellows, and finally grays, indicate areas of much lower ultraviolet radiation. What's significant to the story of human skin pigmentation is just how much of the northern hemisphere is in these cool gray zones. This has tremendous implications for our understanding of the evolution of human skin pigmentation. And what Darwin could not appreciate, or didn't perhaps want to appreciate at the time, is that there was a fundamental relationship between the intensity of ultraviolet radiation and skin pigmentation, and that skin pigmentation itself was a product of evolution. And so when we look at a map of skin color and predicted skin color as we know it today, what we see is a beautiful gradient from the darkest skin pigmentations toward the equator and the lightest ones toward the poles. Now, what's very, very important here is that the earliest humans evolved in high UV environments in equatorial Africa. The earliest members of our lineage, the genus Homo, were darkly pigmented. And we all share this incredible heritage of having originally been darkly pigmented 2 million to 1.5 million years ago. Now, what happened in our history? Let's first look at the relationship of ultraviolet radiation to the Earth's surface. In those early days of our evolution, living at the equator, we were bombarded by high levels of ultraviolet radiation. The UVC, the most energetic type, was occluded by the Earth's atmosphere, but UVB and UVA especially came in unimpeded. UVB turns out to be incredibly important. It's very destructive, but it also catalyzes the production of vitamin D in the skin. Vitamin D being a molecule that we very much need for our strong bones, the health of our immune system, and myriad other important functions in our bodies. So living at the equator, we got lots and lots of ultraviolet radiation, and the melanin, this wonderful, complex, ancient polymer compound in our skin, served as a superb natural sunscreen. This polymer is amazing because it's present in so many different organisms. Melanin in various forms has probably been on the Earth 1 billion years and has been recruited over and over again by evolution, as often happens. Why change it if it works? So melanin was recruited in our lineage, and specifically in our earliest ancestors evolving in Africa, to be a natural sunscreen, where it protected the body against the depredations of ultraviolet radiation, the destruction or damage to DNA, and the breakdown of a very important molecule called folate, which helps to fuel cell production and reproduction in the body. So it's wonderful. We evolved this very protective, wonderful covering of melanin, but then we moved. And humans dispersed, not once, but twice, major moves outside of our equatorial homeland, from Africa into other parts of the Old World, and most recently into the New World. When humans dispersed into these latitudes, what did they face? Well, conditions were significantly colder, but they were also less intense with respect to the ultraviolet regime. So if we're somewhere in the northern hemisphere, look at what's happening to the ultraviolet radiation. We're still getting a dose of UVA, but all of the UVB, or nearly all of it, is dissipated through the thickness of the atmosphere. In the winter, when you are skiing in the Alps, you may experience ultraviolet radiation, but it's all UVA, and significantly, that UVA has no ability to make vitamin D in your skin. So people inhabiting northern hemispheric environments were bereft of the potential to make vitamin D in their skin for most of the year. This had tremendous consequences for the evolution of human skin pigmentation, because what happened, in order to ensure health and well-being, these lineages of people dispersing into the northern hemisphere lost their pigmentation. There was natural selection for the evolution of lightly pigmented skin. Here we begin to see the evolution of the beautiful sepia rainbow that now characterizes all of humanity. Lightly pigmented skin evolved not just once, not just twice, but probably 3 times, not just in modern humans, but in one of our distant, unrelated ancestors, the Neanderthals. A remarkable, remarkable testament to the power of evolution. Humans have been on the move for a long time, and just in the last 5,000 years, at increasing rates over increasing distances, here are just some of the biggest movements of people, voluntary movements in the last 5,000 years. Look at some of the major latitudinal transgressions, people from high UV areas going to low UV, and vice versa. And not all these moves were voluntary. Between 1520 and 1867, 12,500,000 people were moved from high UV to low UV areas in the transatlantic slave trade. Now, this had all sorts of invidious social consequences, but it also had deleterious health consequences to people. So what? We've been on the move. We're so clever, we can overcome all of these seeming biological impediments. Well, Often we're unaware of the fact that we're living in environments in which our skin is inherently poorly adapted. Some of us with lightly pigmented skin live in high UV areas. Some of us with darkly pigmented skin live in low UV areas. These have tremendous consequences for our health. We have to, if we're lightly pigmented, be careful about the problems of skin cancer and destruction of folate in our bodies by lots of sun. Epidemiologists and doctors have been very good about telling us about protecting our skin. What they haven't been so good about instructing people is the problem of darkly pigmented people living in high latitude areas or working inside all the time, because the problem there is just as severe, but it is more sinister, because vitamin D deficiency from a lack of ultraviolet B radiation is a major problem. Vitamin D deficiency creeps up on people and causes all sorts of health problems to their bones, to their gradual decay of their immune systems or loss of immune function, and probably some problems with their mood and health, their mental health. So we have in skin pigmentation one of these wonderful products of evolution that still has consequences for us today. And the social consequences, as we know, are incredibly profound. We live in a world where we have lightly and darkly pigmented people living next to one another, but often brought into proximity initially as a result of very invidious social interactions. So how can we overcome this? How can we begin to understand it? Evolution helps us. 200 years after Darwin's birthday, we have the first moderately pigmented president of the United States. How wonderful is that? This man is significant for a whole host of reasons, but we need to think about how he compares in terms of his pigmentation to other people on Earth. He, as one of many urban admixed populations, is very emblematic of a mixed parentage, mixed pigmentation, and he resembles very closely people with moderate levels of pigmentation who live in Southern Africa or Southeast Asia. These people have a tremendous potential to tan, to develop more pigment in their skin as a result of exposure to sun. They also run the risk of vitamin D deficiency if they have desk jobs like that guy. So let's all wish for his great health and his awareness of his own skin pigmentation. Now, what is wonderful about the evolution of human skin pigmentation and the phenomenon of pigmentation is that it is the demonstration, the evidence of evolution by natural selection right on your body. When people ask you, what is the evidence for evolution? You don't have to think about some exotic examples or fossils. You just have to look at your skin. Darwin, I think, would have appreciated this, even though he has skewed the importance of climate on the evolution of pigmentation during his own life. I think were he able to look at the evidence we have today, he would understand it, he would appreciate it, and most of all, he would teach it. You can teach it, you can touch it, you can understand it. Take it out of this room. Take your skin color and celebrate it. Spread the word. You have the evolution of the history of our species, part of it written in your skin. Understand it, appreciate it, celebrate it, go out. Isn't it beautiful? Isn't it wonderful? You are the products of evolution. Thank you.